So today's question is page 47, figure 3.27. So they've given us an elevation of two solids, okay, A and B. So cone A, sphere B. Cone A has an apex of 86 and has a diameter of 80, and sphere B has a radius of 24. And I want this first part, so remember, try not to be looking at all this, focus on the question itself. Draw the elevation and plan of the two solids. First and foremost, let's get that in. Elevation and plan of the two solids. Alright, so 86 at the top, so just give ourselves enough room there. Our X and our Y. Now, we'll do our cone. So it tells us it's 86, so it's 80 wide, 86 tall. 80 wide. Plug in our elevation and our plan. Okay, there's the apex. Nice and light now when we're doing these, just in case we have stuff that's going to be removed. We can heavy it in right at the end. Alright, now that is A, as it tells us. Now we're going to pop in sphere B, tells us it's 20 away here. But center point is 20 away, and it is radius 24. So step up 24 off the ground because it's resting on the horizontal plane. Alright, that is B. Now, I'll pop it in down below as well. That's our elevation. Now let's do our plan. Out of our cone. Now, circle's down here somewhere, our sphere. So we're going to drop down our center. So this is A. I'll just put that back up there. Drop down our center point. Okay, now we don't exactly know where it lands. So therefore, we need to rotate our object. We need to get our cone and our circle, and we're going to turn them till we're looking straight in. So we're going to turn these till we're looking straight in at them, so we can get an edge view of the sphere making contact with our cone. Alright, so from the edge of this, so we want to move B over, so we're going to move the center point over that way. So we're heading in this direction at the center point, and we know the radius is 24, so we're going to step out 24 from the edge of our cone. Because if it's resting against the cone, the sphere is resting against the cone, then it should have its center point 24 millimeters away. So that is the radius. Okay, so parallel off the edge of the cone, out 24 millimeters, bring them down. Where they cross over, that is the center point. Now, I'll swing it anyway, alright, because we want to use it for point of contact, but you don't have to. Alright, so there is our sphere. We want to put it in nice and light now. Alright, so nice and light. Now, because we have moved our sphere and our cone, we've turned them, so we're getting an edge view. We also need to twist the plan to an edge view. So we're going to put in our horizontal line through the center point. We're going to drop down the center point of our sphere B to here. So that's it, and it's edge view now. And what we need to do is rotate it back into position to make our connection here. So our crossover to find our center point. So stretch it out to there from the center point A, because that's what it's rotating on. You're going to spin it now. So we're going to drop it down. We're going to rotate it. We've already dropped this one down. And where the crossover here, that is our center point. So there's our center point. And we'll pop this in. Again, we're going to keep everything nice and light to start off with, okay? Because we have more going on in this question. So this is sphere B. Now, while we're here, we're going to get its point of contact, all right? So joining the center points of two circles, so that would be in plan. We know point of contact's in here somewhere, so we can't find it just here yet, but we'll find it in a second. But we can find it up here in our elevation. So what you're going to do there is you're going to go perpendicular off the edge of the cone from the center here, all right? So perpendicular from the edge through the center of the circle. Where it makes contact here, that is the point of contact, all right, on its edge view. So we are going to drop it down then to where it's on its edge here. You're going to do your rotation. All right, we're going to do our rotation. Where the crossover there, that is the point of contact. Now you're going to go reverse and you're going to go back up again. Back up to here. Sorry about that noise. So from the point of contact, you're going to bring it across then. So what we've done is perpendicular off the edge, where they meet here, that's your point of contact. You're going to drop it down. You're going to rotate it around. We're going to join our centers. Where they cross over is the point of contact in its proper location. You're going to bring it back up. All right, and we'll bring this across. Where they hit there, that is it in its correct location for our object B to A. Now, that's the first part. So draw the elevation. Now the second one, draw the projections of another sphere C of 40 millimeters diameter, which is in contact with the sphere and the cone in position S. So the image has a position S to be here. So somewhere we're going to have a sphere in there. Another sphere. So it tells us it's 40 millimeters. So 40 millimeters. Alright. And the center of the sphere is to be 50 millimeters off the ground. So first things first. 50 millimeters center point is going to be off the ground. So I'm going to pop 50 millimeters off the ground over just to one side, and we're going to get a light line and we're going to send it across. So we know somewhere along here we're going to have our sphere because it's 50 millimeters off the ground. Now we're told that it's 40 millimeters diameter, so therefore it is a 20 millimeters radius. So what you're going to do, just like we would have done here. So what we need to do it, first of all, we need to find a sphere in contact with our cone. Then we need to find a sphere in contact with our sphere. And when we find them, we're going to combine them to get its current or its proper location. All right. So just like we did out here to find the point of contact, to find its location, the sphere B out here, we're going to do the same thing to the cone, but we're going to do it over here, just so it's not all kind of cluttered up on top of each other. So the radius we said was 20. So what you're going to do is you're going to measure out 20 from the edge of the cone in elevation. We're going to do our sliding set squares again. So get the edge of the cone. Okay, where they cross over. That is the edge view of our sphere C. So where they cross over, that is the edge view of sphere C. Alright, let's write down C. While I'm here, they'll always look for points of contact. So while I'm here, we do our point of contact. So get your edge view, or get the edge there of cone, 90 degrees through the center, perpendicular off that. There we have it here, and that is P there. Alright? Now I'm just going to find the two of them up here first. Then we'll bring them down in a second. Alright? So, found it up here on its edge. Now I want to do the same to sphere B. Now, with a circle, or with two circles in contact, two spheres in contact, you add the radiuses. So, we have B is 24 and C is 20. So together then, we're looking to set our compass to 44 millimeters. Alright? So setting the compass to 44 millimeters. So add the radiuses, or the radii, that gives you our center. So there it is here. To get it on its edge view, put your steel bit in the center of the circle here. There's our 50, which is the height off the ground. Swing the arc where they cross over. That is the center point. Compass on that arc. And we're going to swing our circle. Swing them light again. Remember, this isn't their fixed position. Alright, so that is sphere C, which is touching off sphere B. Just like in plan, to get the points of contact, you join the centers of two circles. Join them together. Where they cross over here, that is the point of contact. Now, this is our setup and elevation. We're going to bring it down into plan, spin them around to make them hit off one another. First, we'll go back and we'll do sphere C in contact with A. So we've moved it to the edge. Alright, so we need to drop its center point down to the edge. Alright, so you can see it's just slightly inside our circle A, which is A1. Stretch the compass out, meet it there. I'm going to rotate that around. We don't know exactly, we just know this is where it's going to end up, so therefore it must end up down here somewhere. So we're just going to send that in here nice and light. Don't know exactly where it's going to stop, but it's sent in anyway. Alright? Now we need to do B. So we've made them in contact with one another. Now you have to just remember, to try not to make the mistake this time. When we bring down the center point, we don't stop here, because this would be the horizontal line that we're using for the cone. We're now working with B and C, pretending A doesn't exist, B to C. So we need to bring C down to hit off A down below. So that's where some people can mess up, alright? So light line out, because we're doing an edge view, so therefore they have to connect here, alright? Bring down our center point. There it is there. Alright. Compass now, stretch it from the center of sphere B out to where we found the center point of C. And you're going to rotate that around till they cross over and make a little X here. That is the center point, so, of our location for sphere C. Now C is up top, so therefore it's above all the objects, so that's actually going to go in nice and heavy. Alright, so that is sphere C. We found its center point. You can now bring that up to elevation. We know it's on this 50 line, so there it is there. Now it's between cone A and B, so it's probably tucked a little bit behind B, so we'll see where it makes contact. So it's in front of A anyway. And as it come down to here, yeah, it gets tucked in behind B ever so slightly. So we'll have a little bit of dotted line there. Alright, and that is sphere C. Now what we'll do We'll heavy up our object and then we'll go get our points of contact. So we'll heavy this up. Alright, so that's that one. So cone A is kind of at the back of everything really. Alright, back to our compass again. We'll go to B, heavy B in, so B in elevation is going to be the front in everything. Alright, so that's ABC. We're here. So remembering now that C is on top of B, so therefore it's dotted. Dotted line, and A is at the bottom. All right. Now, last but not least, they ask in the final bit there, show all points of contact. So we already have the point of contact for A to B. We have found them under edge use the point of contacts from C to A and B to C. Now we just need to transfer them down. So it takes point of contact here from C to A, drop it down to this line. We're going to get our compass and we're going to rotate it. I'm going to rotate that. You're going to join your centers. So A to C are centers. Where to cross over there, that is the point of contact there. And last but not least, we will take the point of contact between C and B. And we're going to rotate these. And we are going to join B to C, the center points. And there we have P to point of contact. Alright, that's in plan. Now, transfer back up. Take it from plan up into elevation, across, then so that's one there. This is where people can forget. They can forget once you find one here to bring them back up again. And C to B. Join B to C center points. Cross over there, and that is P for point of contact. Alright, that is your question complete then. Alright, so that's page 47. Okay.